Oh, I didn't see you there. Hello, and welcome to everything you ever wanted to know about dengue fever.
Dengue fever is a tropical disease caused by an enveloped icosahedral, positive sense unsegmented, single-stranded RNA virus from the Flaviviridae family. This contains such causative agents which also happen to cause yellow fever and hepatitis C. Confused? Let's break this down for you. We are all familiar with viruses in one form or another, but the science behind them can actually be quite complex. The viruses are all essentially genetic information wrapped up in a protein. In the case of dengue fever, the genetic information is RNA, which is very similar to DNA, but is slightly different structure, and it's a little bit less stable, but it essentially encodes the same things by producing proteins. The protein which it's wrapped up in forms a 3D structure called the capsid. And the capsid, in this case, is an icosahedron, which simply refers to the shape. The capsid is then surrounded by a glycoprotein, which is essentially just a protein attached to a sugar molecule. The symptoms of dengue fever tend to vary. Usually you get the rash at the onset of the disease and at the end of the disease. The other symptoms include headaches, fevers, and pain in the muscle and bones. When dengue fever progresses, it can become dengue hemorrhagic fever. This is a disease which affects the blood and the circulatory system. So the blood will then have a lower count of platelets, so that will reduce clotting significantly. And it will also have fragility of the blood vessels, usually the capillaries, which leads to the other symptom of easy bruising beneath the skin. Dengue shock syndrome is essentially the same as the hemorrhagic fever, but in this case it will present more with failure of the circulatory system. When this happens, the mortality will jump to up to 20%, which is very, very high for a disease of this type.
Dengue fever is a growing problem both in its spreading and its intensity, which means that currently its global distribution remains highly uncertain. This is partially due to problems in diagnosis and the vast differences between different countries' national health services, which means at the moment that you can't really accurately estimate the distribution of the disease. A number of different studies have shown that the disease is concentrated around the equator in places like South America, Brazil and Mexico, with a higher concentration of disease being reported in East and West Africa. There have also been a number of instances in Southern Asia and Northeast India, with a 30-fold increase in the disease in the last 40 years. But this could all change with the effects of climate change. Just a 1 degree Celsius increase in temperature could substantially increase the transmission potential.
The primary vector of the dengue virus are mosquitoes within the Aedes genus, most commonly the Aedes aegypti. Many viruses and parasites are transmitted by mosquitoes. A famous example of a virus transmitted by mosquitoes is yellow fever, which has already been mentioned, which is also transmitted by the Aedes genus. Another example is Plasmodium, which causes the dreaded malaria, which is transmitted by the Anopheles genus of mosquitoes. Viruses that are transmitted by arthropods are usually known as arboviruses. The Aedes genus of mosquitoes are usually recognisable as small, black mosquitoes with noticeable white marks on the legs and on the abdomen. The back legs of the mosquito are usually held up in the lyre position. Only the females of the species are vectors of the dengue virus, because they're the ones that feed on the blood meals. The males of the species usually feed on the nectar of flowers. When the female of the species pierces the skin of an infected individual with their proboscis to drink the blood, they also take up small viral particles of the dengue virus. The usual definition of a vector is an animal that carries a virus or disease but isn't infected. This isn't quite true for Aedes aegypti. The virus itself infects the stomach lining of the mosquito. The effect of this is it weakens the immune system itself of the mosquito. As the virus develops in the stomach lining, it moves up the digestive system towards the saliva glands. The next time the mosquito bites an individual, the virus particles move through its proboscis into the individual's blood, further infecting it.
Currently, there are very few options of treatment for dengue fever. There are no vaccines to prevent it, and there are no antiviral drugs to treat it, which means, quite simply, the only way to avoid getting dengue fever is to not be bitten by the mosquito. There is no treatment specifically for dengue fever, and therefore it's a lot easier to prevent transmission rather than trying to treat it. All that can be done is carefully managing fluids, which basically means to drink as much as possible when you think you're infected. Ideally, as much as possible will be given orally, but if for some reason this isn't possible, you can also get it intravenously. There are 4 serotypes of the dengue virus, and if you're infected with one, then while that will give you long-term immunity for that specific serotype, the remaining 3 will only have a short-term immunity. Additionally, one of the risk factors for dengue hemorrhagic fever is previous infection from a differing serotype. This means that a vaccine that can be used must provide protection against all 4 serotypes simultaneously, which unfortunately does not exist at this time. A further problem with creating a vaccine is that there are no animal models. This is a problem as while other species, such as non-human primates, can be infected, they show differing symptoms to humans, and so it is not possible to use them as models. This also means it is difficult to see whether different treatments and drugs will be effective or safe to be used on humans. Currently, there are some vaccines being developed, however these are quite a long time from completion. Complete eradication of dengue fever is extremely difficult. This is because the Aedes aegypti mosquitoes can use pretty much any body of water to lay their eggs. For example, water on leaves, as long as it is stagnant, then they can lay their eggs there. Most often, mosquitoes lay their eggs in man-made objects, such as car tyres and buckets that have just been thrown away but not properly disposed of. These could easily be cleaned up, which would dramatically reduce the levels of dengue fever in these areas. At present, the most effective way to prevent dengue fever is for the people at risk to simply change their behaviour. This could be achieved by simply wearing clothes that cover more of the skin during daytime and putting up anti-mosquito nets during night on your windows and doors. Alternatively, repellents or bug zappers can also be used.